Hello students, today we'll talk about the concept of permutation. So permutation, the definition is like this. Okay, it's an arrangement of a certain number of objects in order. So there are two keywords in this sentence. The first is arrangement. So to arrange the objects. Okay, and then the second is very important, is in order. Okay, that means the order will make the arrangement different. Here I would like to show you about this concept by looking at the following questions. Now, there are 5 different quotients, MATHS. Okay, let's look at the questions. Is to find the number of permutation in each of the following cases. So for part A, if you want to arrange one quotient from these 5, so that means you just simply take it 1, right? So you can pick M, okay, or you can pick A, or you can pick T, and sure, you can pick H, or you can pick S. So in these questions, you just pick one of them, right? So you only make one choice, and there are 5 choices for you to make. So the answer in these questions will be 5. So how about part B? Now if you want to choose 2 quotients from these 5 and then arrange them in a row, then you can imagine, for example, you can pick MA, or you can pick TS, or you can pick ST, like this. Actually, these 2 are different in permutation because the order is not the same, right? Then do we have any method to find the number of permutation instead of just counting it? So we can now look at the case. In part B, you need to arrange 2 quotients, right? So you can imagine here you have 2 quotients. That means the first one and the second one. Okay, then for the first one, which quotient can be arranged? You can arrange the M, or you can arrange the A, or you can arrange the T, or you can arrange the H, or you can arrange the S, right? So for the first one, you get 5 choices. And simply like what you have learned in session 10.1, this is the first step. And now, imagine if you have chosen 1 for the first place, then how many quotients or how many choices can you choose for the second place? So after you pick the first one, then you have 4 left, right? You only have 4 left. So this is 4. It's just like this is the step 1, and this is step 2, right? So the answer of the number of permutation in part B will be 5 times 4. Okay, and then you will get 20. So you can we can also look at part C, okay? Then you will know more about this. So now if we get 3 quotients, then you get 3 of them, right? Then for the first one, similarly, you should have 5 choices. Then how about the second one? 4 choices, right? And then the third one is 3. So in this situation, you will get 5 times 4 times 3. So finally, you will get 60. So now maybe you can observe, if you only pick 1, then you get 1 number. And in part B, for example, if you get 2 quotients, then you will have 2 numbers, right? multiply themselves, multiply each other. Okay, like for the first one, okay, how many choices, and for the second one, you have how many choices, and then you multiply them together. And for the third case, you get 3 quotients, right? Then you get 3 numbers. So I think actually now you may use 5 to 10 seconds to try to do part D and E. Okay, let's do it together. Okay, for part D, 4 quotients, so you get 4 of them, right? So actually this thinking skill is very important. Okay, later there are more complicated questions. I will show you, okay, one by one later on. So if there are 4 quotients, then the first is 4, and then 5, and then 4, and then 3, and then 2. So finally the answer is 120. And then part E, 4, 5, 3, 2, 1. Okay, you choose this 5, right? So you get 4, 5. 5, 4, 3, 2, 1. Okay, it's also 120. Okay, got it? Okay, I hope you can get some like concept of this permutation. Okay, then now we come to a general case. Just imagine if you have n objects, then what is the number of permutations? But you take just out of them. Here we get a very important constraint. You first imagine it is not repeated. That means no repetition is allowed. Then you have like, now because we take our objects, right? So we get, okay, we get our, okay, imagine you get our space here. Okay, then for the first one you will get n, right? And then for the second one you will get n minus 1. Like this example, you will get the first is 5, and then you minus 1, it become 4 after you pick 1, right? So you get n minus 1, and then n minus 2, and n minus 3. Okay, and then if they are our objects, here, then this is actually, the last one is n minus r minus 1. So and then the number of permutations, okay, you just simply like the example before, you can multiply them together. So n minus r plus 1, okay, becomes this. And then finally, okay, this is actually is very important, okay, and thinking skill. And actually this can also simplify as n factorial over n minus r factorial, which exactly equals to the NPR, okay, which you have learned in the last session. So instead of just counting, you can also use NPR, but here I won't suggest you to use it because actually it is not a must to learn, and it is also very easy to mix up with the next session, which is combination. So now let me show you some more, okay, skills in doing the questions. Now we go to example 10.9. Okay, part A. So now there are 6 colored balls, and then part A, if we all 6 balls are arranged in a row, how many permutation is there? You can imagine if we want to arrange the 6 balls, then we have 6 spaces, right? 6 spaces. Then the first one, how many color you have 6 choices, right? Because it is not pick anyone. Then you have 6, and then after you pick 1, then you get the 5, 4, 3, 2, 1. Okay, and then so here please also write the complete sentence. Okay, in the previous example, I just showed you the concept, so I don't give you the complete sentence or answers. So you should write in this way: the number of permutations required. Okay, we use this word again. Okay, required is 6 times 4 times 6 times 5 and 4 times 3 times 2 times 1. Okay, actually you can write 6 factorial as well. Then we get 720. Okay, now we go to part B. Now part B, instead of taking all 6 balls, we are going to take 4 balls out of the 6 and arrange them in a row. So actually there is a common mistake. You may imagine, okay, maybe wrongly think it is 4 factorial, right? Because 4 balls are picked. Okay, so let's do it together with me. Okay, the answer is actually not 4 factorial. So imagine, okay, for the first one, how many balls are you can you take? Because there are 6 balls, so the answer is 6, right? So after 1 is taken, then you will get 5 and 4 and 3. So the numbers of the arrangement or the number of the permutations is not 4 factorial, okay, but it is 6 times 5 times 4 times 3. Okay, so we get the answer is 360. Okay, so now we go to the last example in this session, which is 10.10. So now there are 5 distinct numbers: 2, 4, 5, 7, and 9. First question is, how many 4-digit numbers can be formed? Okay, so please also notice that, okay, without repetition, so we cannot get, for example, 2, 2, 4, 4 like that of number. And then imagine now we have 4 spaces. So how many choices can be made for the first one? 5, right? And then 4, 3, 2, because you are not allowed to make repeated number. And then so finally we get a total number. Okay, it's just you multiply these 4 numbers: 5, 4, 3, 2, right? It will be 5, 4, 3, 2, and then you will get 120. Okay, B. Okay, we get a more complicated questions. How many 4-digit numbers formed in A are even? So you can listen skills. First, how to make a number even. Which digit will determine whether it is even or odd? And sure, I hope you can know it is the unit digit, right? So if it is odd number, then it is odd, and if it is even number, then it is even, right? So now within these 5 numbers, which of them are even? So I hope that you should know. Okay, 2 and 4, right? So here, if we want the 4-digit numbers to be even, then the last digit must be 2 or 4. So we can only have 2 choices to be put in the last digit. So imagine after you put this number, then you have 4 digits or 4 numbers left, right? So it can be put as the first digit, and you get 3 after you put this 2, and then you get 2 finally. So the required number of 4 digits numbers will be 4 times 3 times 2 times 2, which is 48. Okay, got it? So I hope that you can be familiar with these 2 examples, and now it's your turn to do some quick practice. Okay, and then do some also exercise. And in the coming 2 days, we will be doing more and more examples, okay, together. Okay, see you.